Hi, I'm Dahlia. In this video, I want to give you a quick introduction to Docker and cover the most important concepts you need to understand to start using Docker. I'll be using a Java application for my examples, but the same basic concepts apply for any technology you're using for your applications. Let's say you have an application written in Java, a simple Hello World application, for example. You run it and it prints Hello World as expected. In order for this application to run, your source code is compiled into class files that are executed by the JVM. The JVM is in charge of interpreting your application according to your operating system, and all of this is sitting on top of your hardware. Now you have a coworker who wants to run your application. If the coworker has a JVM already, you can just package your Hello World application into a jar and send it over to them. Your coworker can then take this jar and run your application with a one-line command and get your Hello World message. In this scenario, we may not see the benefits of Docker, so let's explore a more realistic scenario. You have a web application and you're using a variety of technologies. Maybe your application is using a database, for example, MySQL or MongoDB. Maybe it's using an application server like Tomcat or OpenLiberty, and all of this is sitting on top of your JVM. You run your application and it works great on your machine. At this point, you want to share it with a coworker, so you package it up into a WAR and send it over to your coworker to run on their machine. In this case, your coworker can't simply run one command and get your application up and running like our previous scenario. They have to set up their database. Maybe you even offer to help them with that, but you find out they're using macOS and you're on Windows, so you slowly withdraw your offer and tell them that they're on their own. They go off and spend a bunch of time figuring out how to install the database on their operating system. They get it set up, they're excited to get the application running, but then you tell them, no, you have to actually set up an application server too. They go do that, and finally they have their full stack. Then they go to run the application, but then they message you and tell you the app won't start. Your first response is, but it works on my machine. You start debugging and you discover that they're using Java 8 and you used a new feature only available in Java 11. You ask them to install Java 11 and use that to run your application. You keep doing this back and forth until you finally get the app running. And then someone on the testing team asks you for your application so they can test it. And then someone from the deployment team reaches out to you so they can deploy it, or you want to deploy it in your CI/CD pipeline. And you have to go through all that setup over and over again. Then you think there must be a better way. That's when containers come in to help. What is a container? A container is a standard component that allows you to package your application and its dependencies in an easy-to-share way. Some of the most important characteristics of a container is that they're portable, isolated, and lightweight. The name container comes from shipping containers. With shipping containers, you can ship a car or a bunch of apples, and the ship doesn't need to worry about stacking the contents of a container the right way, keeping them at the right temperature, or the contents interfering with one another. As long as you provide the contents in a uniform container, they will be shipped. Similarly, your application can be a standalone application, a web application, an enterprise application. It could be written in Java, Kotlin, Python, JavaScript. It could use databases, app servers, and have whatever dependencies. As long as you package it in a container, your coworker, tester, deployment person, whoever it is, can run your application with minimal work. And Docker is the software platform that allows you to do this. Let's take a look at our application from earlier and see how Docker can help us with our previous scenario through containerization. On my operating system, I'll install Docker and containerize my application and its dependencies. In my case, I'll containerize my application code, app server, along with the JVM. But I'll separate out the database into a separate container since it doesn't need to be closely tied to my application. The question is, how does this benefit me? Well, instead of your coworker having to set up everything by hand and potentially make mistakes in the process, if they have Docker installed, they can instead run a couple of Docker commands that you provide them and get the application up and running. And this setup scales a lot better. A common question when learning about containers is, what is the difference between containers and virtual machines? Well, they're both trying to solve the same problem, but they approach it differently. Let's take a look at the virtual machine scenario. If we wanted to run our application in virtual machines, our setup would look like this. We'd have our hardware, which will be running a host operating system. Then we'll have a hypervisor, which creates and runs our virtual machines. When VMs are created, each VM includes its own guest operating system which the application runs on. Unfortunately, having a guest operating system is not cheap resource-wise. With each guest operating system, lots of memory and CPU are taken up. Now let's compare that to Docker. As we've seen before, Docker sits on our operating system layer, but with Docker containers, you do not have a guest operating system, making Docker containers much smaller and faster than virtual machines. When we run our application in containers, we use fewer resources than if we ran them in virtual machines, which allows us to run more containers if we'd like. The startup time on a container is also faster, especially that containers don't have a guest operating system to load. There are pros and cons to using containers versus virtual machines. We won't dive into that here, but the main takeaway is that they both solve the "it works on my machine" problem, but approach the solution in different ways. Now that we've covered the basics and benefits of Docker, we're ready to containerize our first application. In order to understand the process, we'll take the simplest application and containerize it. The first step is to install Docker on your operating system. Second step is to build a Docker image. A Docker image is what will be used to create your running container. It's basically a template which is used to create and run a container. In order to create an image, you need a Docker file which will include the instructions on how to build a Docker image. Third step is to run our Docker container from the Docker image. If you're not sure about the difference between an image and a container, a helpful analogy are classes and runtime objects in object-oriented programming. You can think of an image as a class and the container as the runtime object you instantiate from your class. You take a Docker image and instantiate as many containers as you'd like. So a container is the running instance of your image. Let's go ahead and see all these steps in action. I'll start by creating a simple application. You can use your favorite IDE to do so. I'll create a new Java project. For my Java version, I'll choose Java 11. You can choose whatever version you'd like. I'll select the template option so I don't have to type out the main methods. I'll name my project Hello World Docker and then click Finish. In my main method, I'll print a Hello World string, then I'll go ahead and run it. Here is the current stack of our Hello World application. I want to take this application and run it in a Docker container. First, I need to install Docker. You can install Docker from the Get Docker website. I've included a link in the description. Choose the instructions that go with your operating system. I'm running on Windows, so I've already gone through the Docker installation process for Windows. Once you have Docker installed and have it started, I like to run the Docker version command from my command line to ensure that everything was installed successfully and that Docker is running. I'll open up the terminal window and run Docker version. And looks like we have Docker installed and up and running. Now I'm ready for our second step, which is to build our Docker image. In order to create an image, I need a Docker file. So I'll go ahead and create that by right-clicking on the project, clicking New, File, then entering Docker file. Make sure you spell Docker file as seen here. This file will include instructions on how to build the image for our Hello World application. The order of commands in a Docker file is very important as each line is executed one by one. An image is made out of layers. The first instruction of a Docker file specifies the base layer of your image using the from keyword. Then you specify the name of the base image. With Docker, you get access to a public repository for Docker images called Docker Hub. You can browse Docker Hub to see all the images available to you. I've personally found that Docker makes it a lot easier to quickly set up a database. I've used the MySQL image lots of times. An important note here is to be careful when you're pulling images from Docker Hub. I only pull official images or images from trusted sources. Now back to my application. Since I'm using Java, I'll use the OpenJDK official image as my base image. Then I will specify a colon and a tag. In my case, I'll use the 11 tag, which is the tag for Java 11. I could also leave the colon off and the tag off, which will pull the latest OpenJDK image. In my Docker file, I can add comments with the hash sign. For my next instruction, I will create a new app directory for my application files. I will use the run keyword followed by the make directory command with the directory name. A Docker file can have multiple run commands. An important note here is that when you're using the run command, you're executing commands for your image, meaning that this line is creating a directory that will live inside your container, not your host machine. Next, I need to copy the application files from my host machine into the image file system. So I will use the copy keyword, then specify what I'm copying from my host machine. In this case, it's my main class file located in the out directory. Then the second argument is the directory in the image where the file will be copied. I want to pause here and talk about the difference between the copy and the run keyword. I used to get confused on when my instructions apply to images versus host machine. So what really helped me is to remember that when I use run, the commands only apply to images. But when I use copy, the first argument applies to my host machine, but the second argument applies to the image. For my next instruction, I need to set the directory where I'll be executing future commands. I can do so with the workdir keyword, then specifying the app directory. Lastly, every Docker file needs to specify the command that will execute when you start a container from the image. Your Docker file must contain one command or entry point instruction specifying the default instruction for your container. In my case, I want to run my main class when my container starts. I'll use the command keyword, then specify the command I would have run if I was trying to run my main class from the terminal, which is Java main. And that's all we'll have in our Docker file. The file basically says, pull an OpenJDK image, copy my application files into the image, and run the application when the container starts. There are lots of keywords you can use in a Docker file, but these are a good starting point. Now that we're finished writing our Docker file, we're ready to build our image. You can use this icon in IntelliJ IDEA to build your image, or you can use the terminal. Let's see how we can do this in the terminal. We'll run the docker build command, then I'll use the -t option to specify my image name and tag. I'll call my image hello world and give it a 1.0 tag. You could also not specify a tag and it'll default to a tag called latest. Then I need to specify the path where my Docker file is located. Since I'm already in the directory where the Docker file is located, I can just specify a dot here for my current directory. Now let's run this command. The command is running and you see the output here, including the result of each instruction in my Docker file. When the from OpenJDK 11 instruction is executed, Docker will look for the image locally, and if it doesn't find it, it'll pull it from Docker Hub. Since I currently don't have the OpenJDK image locally, this build is taking a little bit of time, but the subsequent builds won't take as long. Then we see the rest of the Docker file instructions running successfully and our Hello World 1.0 image is built. If we want to see a list of the current images we have, we can run Docker images. You'll now see that my Hello World image is listed with the 1.0 tag. You'll also see the image ID, when it was created, and the size of the image. At this point, we haven't actually run any containers yet. We just created an image. So I want to instantiate my image and run my container based on this image. We can do that with the docker run command and specifying the name of the image that the container will be based on. Once I execute the docker run command, Docker will create a new container and run it, which prints off a hello world message. This time, the hello world message is coming from our application running in a Docker container. If we want to see the list of currently running containers, we can run the docker ps command. You'll notice that our container isn't listed here because our application prints hello world and immediately terminates. Since the docker ps command only lists the containers currently running right now, we don't see our hello world container. Instead, if we want to see a list of all containers, including running and stopped containers, we can run docker ps-a. Now we see our container that already ran and terminated. The docker ps command lists all the containers information, including the container's ID and the image this container was based on. You'll also notice that since we didn't specify a container name, Docker gave it a random silly name. Now let's change our application code a little bit to mimic the behavior of a continuously running container. I'm going to add a loop that prints a message every 2 seconds. You can imagine this being your own web application running in the background. I've finished up my source code changes, but those are not the files going in my image. When my image is built, Docker copies the class files, so I need to trigger an update to my class files. I can do that by rebuilding my project, which I will do that here, or you can simply run your application. The important part here is that when you're making application changes, make sure your class files are getting updated so that when the new image is created, those new classes make it to the new image. Now that my class files are updated, let's build a new image using the same build command from earlier, but this time I'll give my image a 2.0 tag. The command runs and you'll notice that it takes less time than last time we ran this command because we already have the OpenJDK 11 image pulled. Now let's run a new container from my 2.0 image. This time, I'm going to run the container in detached mode using the -d option, which means that the container will start and run in the background without taking up my console window with all the messages being printed every 2 seconds. The command executes, which starts the container in the background, and this time the output is the new container's ID. Now this time, if I run docker ps, we see the container in our list since it's currently running. From here, I can start as many containers as I would like. Let's start another container from my 2.0 image. We can just run the same command again. And now if I run docker ps, I see 2 containers. If I want to see what is happening in my container so far, I can use the docker log command and pass in the ID of the container I want to see the logs of. Notice that I can use the short version of the container ID printed in the docker ps command instead of the very long one that was printed after my container was first created. And looks like my container is currently on iteration 22. If you're using IntelliJ IDEA, you can also see a list of images and containers in the services window. There are lots of Docker features available in IntelliJ IDEA that make developing applications in Docker easier. You can learn more about them through the link in the description. And this wraps up our video. I hope it was beneficial and you can now get started using Docker with your applications. Thanks for watching.